So, like an idiot, when I was doing 21, I started doing a binomial expansion. You can see I wrote this down. That's a binomial. We did that. It works well for like x minus y to the 10th, and that's a binomial. This is a trinomial. You are more than welcome to go online and look up trinomial expansion. There is a technique for it. You can. It's right here. But I don't think that applies to what you're looking for. And I've never done it. So the only way I know how to do this is to literally write it 10 times. Save this for last. Now I do know that as you do it, you'll catch on that you only need to keep certain terms because you have to generate this. This is what you generate. And it might be something like 33600 x cubed y to the 4th z cubed. But there are things you can throw away as you do it. You won't have to do everything, and it gets huge. Even if I just don't have time to do it. If I was bored, I would. So I'm not going to do it. If log base x is 10 is this number and log base x of 27 is that number, evaluate log base x of 300. Well, we'll see if we can cheat with a calculator. We will, but we'll worry about that later on. So what I'm thinking, and I don't know if it's right or not, this is an old school logarithm problem. All right. Log base x of 3 cubed is 5.18. That's 0.518. So log base x of 3 logs base x of 3 is 0.518. There's got to be a better way to do this, but I can't think of it off the top of my head. And what do we have here? We take that 0.518, we divide it by 3, and I get that log base x of 3 is 0.1727. Now how does that help me? It helps me because log x of 300 is 3 times 10 times 10. And if I use my break apart rules with logarithms, I have a log base x of 3 plus a log base x of 10 plus a log base x of 10. And I have those numbers. This is 0.1721. Each of those is 0.362. So plus 0.362 plus 0.362. 0.897. Now, there might be an easier way to reverse engineer this problem. Let's do log as base, answer, exponent. X to the 0.362 is 10. Y1, Y2, because I don't feel like pushing buttons for a while. Let's see, let's let our window look up at 12. Gonna have to look pretty far to the right, aren't we? Set that X max around 300 and see what happens. Okay, 3,000. There we go, that'll do it. Second trace 5, get close. I lost it. My goal was to get to 10. There she is. Enter, enter, enter. And I got back that X is about 578.66. Let's just say 67. Alright? So now I can do this. This would be the ln of 300 over the ln of 578.67. Lots of ways of doing these things. This one was worth doing. Ln of 300 divided by the ln of, I think I said 578, can't even read my own handwriting, 0.67. Pretty close, huh? Oh, sorry you couldn't see what I was doing. Pretty close. So, that's the two ways of doing that one. Determine the inverse of the function for f of x is 2e to the x minus 3 plus 1. This is an easy problem for y'all. So we swap x and y. We subtract 1. We divide by 2. Now we make our logarithm, which is a log base e. Our argument is x minus 1 over 2, and g equals y minus 3. So it's got to be choice A. Another thing you can do is you can use symmetry. All inverses symmetrical. This is a good test skill right here. All inverses symmetrical with y equals x. So let's look at symmetry here. Let's look at our original equation. She was 2. And these are horrible, so some kids can't see the symmetry and some can. It just depends on your spatial skills. And just take a look at her on the standard zoom 6. There's 2 to e. Its inverse ought to look something like this. Let's put the line of symmetry in y2, and our suggestion, at least my suggestion, was that that's the inverse. There's your line of symmetry. Oh yeah, the calculator can't draw logarithms. That's kind of a big thing. It's worth remembering. TI-84s don't draw the full R. I should say lowercase r, because they don't. But there's your inverse. It reflected like it was supposed to. So maybe you understand reflection, maybe you don't. I don't know. Identify the polynomial with integer coefficients of lowest degree that contains 2 plus root 3 and 5i as sum of the roots of the function. So these are the complex conjugate theorems. And it's a really simple theorem. It says weird zeros have conjugates. So if 2 plus root 3, I'm also 2 minus root 3. If 5i, I'm also negative 5i. So let's write out some factors here. One of our factors is x minus 2 minus root 3. And the other one is x minus 2 plus root 3. Now, we're going to figure out what this creates. That creates, obviously, x squared. Minus 2x, another minus 2x, so there's minus 4x. It creates a negative 2x here and another negative. I already did that one, didn't I? Oops, sorry. Did that one, that one, that one. Okay, I got out of order. It creates a plus x root 3, and it creates a minus x root 3. And then it creates a minus 3. What else does it create? It creates a negative 4 root 3. It creates a lot of hideous stuff, doesn't it? No, it doesn't. Those cancel each other out, because this one would be positive and that one's negative. So that's what it creates. And it looks like this. That's not too bad. It's really not. Writing out these as factors, you would have x plus 5i and x minus 5i, which really works itself out nicely, because you'll have x squared plus 5ix minus 5ix and then minus 25i squared, which you know is positive 25. And does that give us enough information here? So let's take these two guys, x squared minus 4x. You know, I'm doing this probably the entire hardest way possible. You'll have x to the fourth plus 25x squared minus 4x cubed minus 100x minus 3x squared minus 75. And if I combine like terms on that, there's negative 7x cubed plus 25x squared plus 22x squared daylight savings time, man, it's got me hard right now. Plus 22x squared, because man, I just can't think. And what I just kept going with this. I have no idea why. Hoping it would lead me somewhere. But this was all nonsense. This was all about. So, let's use the storage feature. If these are roots, then they are zeros. To take away a root 3, store it to x. Sorry I wasted your time there. Let's type in C, D, or E, because I think it's C, D, or E. Obviously, I could be wrong. X to the fourth minus 4x cubed. Let's see, we have a plus 26x to the second. I don't think that's it. But I like the fact that it has the negative 100x. Oh, that's a winner. Let's see if it likes negative 5i. Also a winner. Let's check D. Yeah, D's not a winner. Let's check E. So see, I was sitting over there doing all that stuff, too tired to do it, when in reality is I just had to know how to use the storage feature. That one creates a zero. What represents the solution to a system of equations? Well, let's see. Let's go to second matrix. Now the truth is it should be this one, but let's find out. Second matrix, edit. Let's see what kind of funny answers we get. Let's use a 3 by 4. Again, there's a reason I chose that, but we're going to see what it says. If this has no solutions, then obviously I'll change that answer. I don't know why I did a zoom 6. I have no idea why I did a zoom 6. Second quit, second matrix math. 2 below come sum is double REF. Second matrix A. Now it has answers, and this is an ordered triple. The answers are x equals 4, y equals negative 2, and z is 17. That's an ordered triple. 4, negative 2, 17. So let's just go to Google real quick and ask Google what is an ordered triple. Doesn't really say, does it? There it is. Graphing order triples. You got a point. And let's type in something else. Solving systems of three equations, of three variables, visually. This is why I had a hunch it was a plane. We have a unique solution, which means this is the point where three planes exist. And I don't even know why I said plane. I should not have said plane. It is the point of intersection of three planes. It is the point of intersection for three planes. I'm sorry. It is the point of intersection for three planes. I'm glad I looked that up. I don't know that I should be making a video right now. I was going to check my key, but that's what it is. It's the point of intersection for three planes. Each one of those equations represents a plane, and this is where they intersect. So there we go. That was 25, moving on to 26. And behavior. Oh my God, you guys know this. You know this. I'll be darned. All those MF quizzes, paying off. So you know that negative 4x to the 8th starts low, ends low. Who would have thunk? So as x goes to negative infinity, y goes to negative infinity. That looks good. As x goes to infinity, y has to go to negative infinity. So choice D. Determine the domain of this function. Ugh. Ugh. Now, here's the domain of this thing. You have a logarithm. For a logarithm with an argument, the argument is bigger than 0. So 2x squared minus 21x plus 40 is bigger than 0. And here you have an even root. So for an even root of something, the something must be greater than or equal to 0. You also have 3x squared minus 13x plus 10 being greater than or equal to 0. Now, the truth is, I'm just going to cheat. I'm just going to look at the graph. That's all I'm going to do, is I'm going to interpret a graph. Because I can. I'm feeling kind of numb today, so it's appropriate I use that function. Fourth root is going to be the 1/4 power. And there's my function. Zoom 6. Well, isn't that weird? This thing is going to rise to infinity. It's going to come up from negative infinity because there be asymptotes at 1 and 8. I spelled there, T-E-R-E. That's how tired I am. There are, I'm going to try and write slow, asymptotes at x equals 1 and x equals 8. That's where they are. Now, that does not necessarily mean that I'm choice B. Or does it? If you plugged in a 1, you'd be taking the even root of a negative. My guess is this 5/2 probably comes from there. But yeah, we're going with this one. I wonder what the difference between A and B is. Oh, no, we're not going with B. We're going with A. You can't be that. There's asymptotes there. That's where division of 0 attempted to happen. So if you plug in a 1, let's just try something less than 1. Let's try 0. If you plugged in a 0, you'd be taking root 10. That's fine. If you plugged in a 9, you'd be taking the root of a positive thing. That's fine. So yeah, it's choice A. The graph of the rational function, blah, 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 has an asymptote along which of the following functions? This is best done with long division. The the quotient of long division is the asymptote. So it's a hideous looking thing. We can also do the whole y1, put the answer in y2, and we'll check it. So let's do this hideous math. Did they really have to do x to the 4th? Like, really? I guess they did, because they don't want kids getting these right. It's about time, too. Like, I know a lot of kids finish early. They finish early because they don't know what they're doing. The kid who knows what they're doing is going to use most of that time, plain and simple. Obviously, it's an x squared. Obviously. Use your distributive property, x to the 4th plus 9x cubed plus 11x squared. Right before you subtract, 14 minus 9 is 5. 59 minus 11 is 48, I think. And then carry down that 82x. Now we're going to have to 5 everything and exit, because we want to create 5x cubed plus 45x squared, and then plus 55x. Again, right before you subtract, 48 minus 5 is 3. I think that's enough of a place to start. It is, because I'm going to take 3 times x squared and generate that. There's your answer. I don't know if you remember me doing this in a previous video. Boy, it's going to take some time, but whatever. This is not for me, it's for you, so my time is not important. I did it with the hyperbola, and it's worth talking about. Again, the point here is to try and learn how to take a test. And the less mental power you have to do with this thing, you can save it for that one that you had to write 10 times. I wish I knew a shortcut to that one. I do know that if you'll write that thing out 10 times, you'll catch on, I want to say fairly quick, but within 5 minutes, that you only have to keep certain things. Anyways, what's that hideous graph look like? Oh, it looks like that. It probably has an asymptote, parabolic in nature. All right. So let's just take a look at some of these that aren't the answer. Yeah, that's not an asymptote. See, that had what, a plus of 59? Let's look up 70. Not an asymptote. It's hitting. This one's probably close. I'm going to hit the graph key since I've already got a good looking window now. Not an asymptote. And what do we think the right answer is? Plus 3. Looky there. It got close, didn't it? But it never touched it. So there you go. All right, 29. Which statements are true for the graph of the rational function? First one says the graph does not have a vertical asymptote. That is a lie. Again, if it's talking about a graph, I'd be a moron to not look at the graph. I mean, yeah, there's things you're supposed to know. Like, I'm very confident it has a vertical asymptote. Will the calculators show it, though? Of course, calculators don't show it. I guess it's fully possible to generate a question that'll kind of trump a calculator. I don't know that I typed in the bottom properly. No, I didn't. It should have a vertical asymptote at x equals 0. But it might also have a hole in the graph. It has a VA. It's got two of them. It's got one right here, and it's got one right there. So this is, anything that talks about choice 1 is off the menu. Graph has a vertical asymptote at x equals -7. That is probably true. VAs happen when division of 0 happens, so let's factor that. That's x times x squared plus x minus 42. Set it not equal to 0. That'll factor as plus 7 and minus 6. So, yeah, x cannot be 0, x cannot be -7, and x cannot be 6. So this is true. Talk about having a hole at 6. It does have a hole. You'll notice that on your graph, it drew it at 6, but let's hit second trace 1 for value. When x is 6, there is no output. Nothing. The reason that happened was because of how this thing factored. Of course, the bottom was x times x plus 7 times x minus 6. The top factors as x minus 6 and x plus 5. And what these things did is they canceled each other out. But you guys know domain. You know domain. X cannot be 6. The simplified function doesn't have that, but the original function did. So also true. It's 2 and 3 only. Good little problem. Ooh, geometry. A triangle. Love triangles. Has two sides of lengths 5 and 7 with an included angle measurement of 50 degrees. Which of the following is a possible angle measurement for the other side? So it's included, which means it lies between. That's what included means. It means it lies between 5 and 7, and they want this unknown side length. I believe you're going to do law of cosines, which says c squared is a squared plus b squared minus 2ab cosines of angle C. And I don't know what c squared is, so it's x squared. 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of angle C. Oh, which by the way is 50 degrees. And it is a degree. So let's go to mode, degree, blah, blah, blah. We got 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of 50 degrees. Then we take the square root, and we get 5.39. Now how does that help me? Because now I can use law of sines. Remember her? The sine of 50 compares to 5.39, and let's just pick a side as, I don't know, let's call this angle Z. as the sine of z compares to 7. So if you're following along, I'm not going to write all this out. That was my lunch bell. 7 sines of 50 would be divided by 5.39. I would then take the arc sine of that answer, and I would get 84.2 degrees. Let's see, let's add our 50. 180 minus 45.8. So I guess the one we have here is 84.7. And you know, I rounded this. This was rounded. Let's try not rounding. 7 sines of 50. It would get divided by, sorry, you can't see what I'm doing. That. And the arc sine of that is closer than what I had. That's 84.66. I had 84.18, so rounding. The stuff we're doing now. For an angle in the first quadrant, the cosine of theta is 8/17. Determine the value of the sine of twice theta. So what I'm going to do is I'm going to find theta. Theta is the arc cosine of 8/17. I don't expect you to remember this identity. The author of the test does. But they're also hoping that you're, at the same time, that you can do stuff like this. So theta is 61.928 degrees. Now twice theta would be, according to my little TI-84 here, 123.855 degrees, which is a second quadrant angle, and thankfully, by all strippers taking cash, still positive. It is for sine anyways. Anyways, let's take the sine of that thing. We get 0.83044. Let's see what choice D is. 240 over 289. That's her. Sweet. Which of these expressions simplifies sine to the fourth minus cosine to the fourth of the same thing? So let's cheat. Let's do theta. We can do this by hand too, but let theta be like 30 degrees. All right. So we have sine to the fourth of 30 degrees minus cosine to the fourth of 30 degrees. And I just picked something I knew what it was. What is this? We could probably factor it as a difference of two squares. I'm pretty sure that's where the author of this question wants you to take it. Or we could just figure out some numbers. If I think about the unit circle, the sine of 30 is a half. And the cosine of 30 is root 3 over 2. So a half to the fourth power should be a 16th. And root 3 to the fourth should be 9. And I'm left with negative 8/16, which is negative 1/2. Right? Seems right. Anyways, it's not A. They're hoping that on A somebody thinks sine squared plus cosine squared. That's what they're hoping. It's not A. Now, what do we have here? We have 1 plus 2 cosines 30, cosines 30, cosines 30. That's how you raise something to the fourth power, I think. Cosines 30. Not that one. 1 minus 2 sines 30. Sines 30. Sines 30. Sines 30. Not that one. Tangent 30. Tangent 30. tangent 30, tangent 30. Not that one. And what do we have here? We have negative cosine of twice theta, so negative cosine of 60. It was that one all along, wasn't it? Of course it was. Now, just because I'm bored, let's do something. Let's take that. That's sine squared theta minus cosine squared theta times sine squared theta plus cosine squared theta. This is 1. So I'm left with this. Last I checked I was. That factors as what? Sine of theta minus cosine of theta and then sine of theta plus cosine of theta. Actually, I did too much work on that one. I've probably lost my little cheat sheet here that I had because I think I gave them all away. Let's just look up some trig identities real quick. That's sine squared. This is what I need. Sine squared minus cosine squared. So let's look up the cosine of 2x identity. It's right there. It's the first one. And why is it negative? Because we have it the other way around. We have sine squared minus cosine squared. But anyways, you didn't have to know any of that. Identify all the angles over the interval from 0 to 2 pi that make the equation true. Y1, Y2. That's all I'm going to do on this, man. Sometimes I wonder why we teach trig. Now, in order to type this in TI-84, you're going to have to type 3 tan. And then we have a minus 1. We put a 0 in Y2. We want to be in radian mode. And our window is going to go from 0 to 2 pi. They have inclusion. This thing is going to have multiple answers. And then graph. Did I put a 0 in Y2? I did, good. I have 1, 2, 3, 4 answers. This makes sense, but just to check them. .618 .5236 A lot of kids can do trig. The problem is they don't get all the answers. 3.6652 5.7596. So let's just check our answers and see if they make sense. We got a 4 pi over 3, 7 pi over 6. Okay, so 4 pi over 3 didn't work. This is why I checked. We have a pi over 3. Not an answer. We have a pi over 6. Did I put the minus 1? 3 tangent squares minus 1, it's there. 0.52. So, nice. They tried to trick you. Now, you know what? Let me check the key on this one. It says all the angles. All the angles. Let's see, this was the year 2022. What number are we on? 33? Pre-calc. Key for 2022. 33. E. Makes sense. It does. It's none of the above. None of the above. Because they didn't have them all. They just tried to trick you. Oh, I'm so close to being done with this, man. So close. Oh, you have no issue with 34. You know that period is equal to 2 pi over b. So the period is 2 pi over a third, which is 6 pi. Easy peasy Japanesey. Parametric equation. So this is kind of cool. I'm glad this showed up. What we're going to do is we're going to simply hit the mode key. And we're going to change it to parametric. These are used for studying the heavens. Parametric equations are often used in astronomy. They really are. And then we have sine 3 pi t. I'm too tired to tell you why right now. Whatever text I read is just not there, and I can't regurgitate it. Over the interval from 0 to 10. Let's see here. So we have a t-min of 0, t-max of 10, and a graph key. And I don't see anything. Am I still in degree mode? I'm still in radian mode. I see nothing. Nothing. I can tell you the sine period. Oh, we got that t there, which makes things weird. Just do a zoom 6. There we go. Zoom 6 showed something. That's good. It's weird that it looks like that. So what do we have? We have a sine curve oriented from left to right as t-values increase. It is oriented from right to left as t-values increase. It starts on the right and it works its way left. So anything that's left to right is gone. What's its period? Well, let's take that -2 and stick it there. We'd have negative 3 pi times a 2 x. Think about that. So we'd have negative 6 pi x. And period would be, God bless me, I'm tired, 2 pi over negative 6 pi, which is not agreeing with what I was hoping it would agree with. I was really hoping this would do the job. So scratch that thought. Play with the window. It doesn't have much of a period, does it? Let's see, if we have a period of 4 pi over 3, and we know it's running left to right, let's make the x min negative 4 pi over 3, and the x max 0. That's more than one period, isn't it? Okay. Let's make the x min negative 4/3. That's it. See, I didn't even have to explain what parametric equations are for you to be able to answer the question. Now, did I? And that is where I am stopping, because I need to go eat lunch. I will try and finish the rest of this tomorrow morning.